Sir, my name is Narendra. I explain about the Excel design project with the relation method with machine learning. Subtopic is neural network. Integration domain models in domain in machine learning. With ability to represent the complement and non-linear intersection among the input variables and target responsible. As compared to the classic relation model, the neural network can represent various of patterns since the feasibility of architecture in form of layer and neurons. The regression line app in MATLAB often conveys interface of applying machine learning technique to regression problems in form of different configuration of neural network. The configuration depends upon number of filter F as FC layer and number of neural networks in each layer. Particularly, neural network is containing to one FC layer of 10 neurons. A minimum neural network has one FC layer of 25 neurons, and a neural network has two FC layers with 10 neurons in each. This work initially investigated how various the what architecture improves the performance of regression tasks in terms of comparison of regression accuracy and generation capacity. Here my problem statement is that the forecast continuous output from the state input futures continues to one of the largest challenge in numerous particular applications. Simple linear regression model tends not able of non-linear relationship. Hence, the leads to suboptimization prediction quality. The aim of this project is to study how the various different neural networks are architected and calculated by the layer and neural count impact the regression model performance under the regression learner setup. During the learning to reduce the prediction mistake and to apply the regression problem, neural networks predict the continuous output values instead of layers or data regression. Regression neural network normally consists of inner layer output and the input layer. Input layer accepts the future variables of data, like independent variables. Hidden layer, one or more layers that map into the input into immediate represent by means of weight sum or non-linear activation function. Out layer that reduce the final continuous values as a prediction. The deep of the learning ability of neural network is determined by the deep of network number of hidden layers, width of the network number of neuron per layer. In MATLAB regression learning app, neural network classified by the architecture. It has the neural network, medium network, activation network, learning processing, and neural design impact. Neural network is a single fuel connecting layer with 100 neurons for simple and linear suppletable problem. This functional complex and fast training. The medium network containing a single fuel connecting with layer with 25 neurons has more modeling power than tiny network. Has ability to deal with modern complex and non-linear relationship. Binary neural network connecting two full connected layers with each 10 neurons at depths and network has ability to learn the hierarchical represent of futures more important of the data with hard to recognize the underlying platelets. Activation function is used to neurons such as RELU, rectified linear network that introduce the non-linearity so the network can learn the complex function. Learning process has consist of forward propagation, loss calculation, and back propagation. Forward propagation input data flows through the layers and prediction made. Loss calculation difference between the predict and actual calculated with the loss function. The network adjusts the weight to minimize the errors by means of optimization algorithm. Network design impact the neural more neural increases the ability of network to learn more features from the data. The raising number of layers assists the network in learning abstract represented by of high level, but more data, more and tuning may be necessary to prevent out of it. Our next heading is data set and pre-processing. Training any machine learning algorithm, it is essential that the data set can be truly prepared by the running a sequence of pre-processing step. Pre-processing enhances the data quality and there is a faster model learner. In many instances, resulting in a problem in prediction accuracy. For example, data set with various input features and continuous output variables is utilized. The input features measurable values such as horsepower, weight, and acceleration, and output prediction as a mile per error. The features are selected since they have strong and through non-linear correlation with output, thus good for training neural network. The process of pipelining begins by importing dataset into MATLAB. Missing values handled by assertion at the point since incomplete or numerous entities will be wisely affected the model performance. Missing data rows are deleted by ensure transparency. The features normalize so that the all input variables have equal contribute during the training day. Without normalization, the features with high numerical range may be overused. The learning process that does unstable model behavior. After normalization, the data is divided into training and test subjects. The training data are employed by the training neural network model. The test data assume how will the model generates new data. Thus, is 70% to 30% division employed provide enough data for both training and evaluation. The optimization pre-processing may involve in the application of future of selection method to eliminate the redundancy and relevant input to provide the model performance and loyal templates. The simple visualization such as scatter plot can also be applied to analyze the future relationship with the target variables priority to model construction. Although the pre-processing is the data is lean and well organized, ready for effective and precision model neural net. The steps model development. The steps of model development. The selecting model architecture. Depending upon the complex of data, three different architecture: narrow, medium, and binary. Selecting inner statement would depend on weight of the frames of performance. Based on this, we select the model architecture. Training data. We select the training data of 70% of data to employ the training the model. The neural network trained by the back propagation algorithm in order to reduce the loss function and typically means square also you use the linear regression method as early shopping or weight detects maybe avoid the overfitting. Hypermeters are set to like activation function, losing function, optimization. Activation for the hidden layers and means square for the continuous output. In Internally use of algorithms such as SGD, store rate, range set, or optimizers to adjust the weights. We now implementing the code information for neural network. First, we have to use CLC, CLA, here, or CL to remove the all clear the command window, CL for remove the all variables from the ground space. Those are for the those are open feeders, not dependent data. Node load the MATLAB building setup. We use fast mode and select the input feature like the horsepower and weight and acceleration. Selecting output variables for MPG means mile per gas. Some rows using have missing NaN value. Idea is finding the rows where none of the future values like x or target values y are n. Only to the complete data load for enable finding or testing. Normalization, we use x equal to normalization x. Okay, now we use the clear not loss on SCB for the 70% training for the train data and 30% for testing data. All the used for 0.2 create the speed too. Training used for train return the training data and test used to return the test. Now you perform the narrow. So, around fit. We use the one layer for 10 seconds, and layer for activation versus standardization truth.
జిరాక్స్ షాప్లో ఉండవురా. ఆహా. సౌండ్ లో తీయాల. రివ్యూ ఎల్లుండి హాక్తాను 29. 29 హాక్తాను రేపు రివ్యూ. అది అందుకే ఇప్పుడు ఇది ఒకటి చేసి నెక్స్ట్ ఇది తర్వాత ఏం చేసుకోవచ్చు. 6:30 లోపు చేసేయాలి మనం. ఇంకెన్ని లైన్లు ఉంది ఇది?
ఇంకా 10 లైన్లు ఉన్నాయి.
ఇంకా 10 లైన్లు ఉందా?
లేదులే, ఇదంతా టైప్ చేయాలి వాల్యూస్.
అదొకటి టైప్ చేసి అదొకటి టైప్ చేసి నెక్స్ట్ ఇది చేద్దాం ఇంకా.
వాయిస్ అయింది కదా.
రెజ్యూమ్ కొంటే స్టార్ట్ చేయి ఇంకా. సరేనా?
We now using so many people. Is do like same here also binary for the values. Now, yeah, now I use plant. I put the dash. Okay. About this one, this is the thought rate data. I view normalization in aspect that one only. Now I explain about this is the remaining toad. Now we run this toad. And then now we run this toad. Here we term the RMS loose error, measure the average magnitude of the precision error, and also measure the how well the mode of federation match the real data. The result printed in here, the performance matrix and narrow NN and medium NN and binary NN. The binary neural network gives the lowest RMS and the highest R square. It shows the addition more than one hidden layer, improves the model learning ability and generation. The medium neural network also perform well, better than narrow, but slightly worse than binary. The narrow network performs reasonable, but was not accuracy compared to larger networks. The visualization product that compares the actual MPG value and versus a predicted value from three models. The close predicted value among the actual and the better the model. The binary and medium neural have predicted the closer the actual values. The narrow network predicted slightly more of true values. The data preprocessing was crucial for the stable model training. The filter function MATLAB provides very efficient and easy way to create and test different neural network configuration for regression tasks. Conclusion. In this project, we successfully executed and completed three neural network architecture, narrow, medium, and binary data for regression tasks using MATLAB inbuilt task model data set. The primary goal was to predict the mile data for various star-based attributes such as horsepower, weight, and acceleration. With institutional training and acceleration and analysis, what is found that Binary layer neural network, one hidden layer with 10 neural networks and another with 10 neurons, always performed better than rest of the models with the lowest RMS and highest R2. The medium neural network, one layer with 25 neurons and also Excel demonstrate the hidden adding more neurons can improve the model performance. Neural network, hidden layer with 10 neurons give the prediction but relate to less accuracy. Showing the smaller architecture maybe not to capture the essence of complex in data. The experiment demonstrated that the following key points. The deeper or breadth of the neural network, the more neurons and layers tends to be enhanced the learning capacity and model prediction and particularly for non-linear patterns in data. Additive data of preprocessing, for example, the creating of the missing values and normalization feature, it is crucial for attending the providing model performance. The methods for evaluating the models such as RMS and R-square are important to measure how well the models work and made the objective comparison various architecture. The visualization of prediction of reality in invalidity of measuring similarity of models, predicting the with actual model improve insight and beyond the numerator outcomes. In summary, the neural network provided robust variation rules of regression problems, selecting the props architecture and depending upon the problem complexity and doing the proper processing and essential for the optimize performance and future result and aim to improve the model performance further. Use tuning the parameters, learning answer, rates and activation function optimization. It is the mode complexity tends to task evaluation methods to improve the model generation. This project show even complexity of the small data sets and neural networks and produce high prediction activities. Careful design of neural network plays important role in all the